In this video, I'll be implementing particle physics in a way that allows me to have over 1,000 particles bouncing around all over the place without any performance issues. There's two videos I really recommend that you watch if you haven't seen them yet. The first one is what most of this code's coming from. It's the particles video I made a couple weeks ago. It goes over the basics of particle implementation and stuff, but it doesn't have any particle physics. That's what this video is for. The other video I'd recommend you watch is my video on physics, actually. It's just tile physics, and that's the same type of physics I'm going to be using here. And there's a really important concept that I'll be using in this video, although I will go over it here. So let's take a look at what I've got here. I've taken pretty much all of the code from my last particles video and I made a couple changes. First of all, I set it up to only create particles when I click. Second of all, it makes 10 particles at once, or for every single frame. And I've also changed the direction. It's just in every direction, even with gravity applied. And up here, I've got a little bit of a tile system. It's just a dictionary with the keys being the location of the tile and then the values being the location and the color. So I've got 16 tiles here. Let's take a look at this setup. Alright, so as you can see, I've got my tiles right here. And I've also got my particles if I left click. This is over 1,000 particles when I've been left clicking for a while. These tiles are what I'm going to make these particles bounce off of. So that's why they're shaped the way they are. I've got this little chamber here so I can bounce them around inside there. Alright, so this implementation of particle physics assumes that the particles only occupy one point in space, or in our case, 1 pixel. I can simplify the collision testing with the assumption that a particle can only be inside one tile at any given point. So when you've got a tile map like this, you can simplify the collisions by just creating the tile location for the particle itself. So in our case, our tile size is 20 pixels. So if you divide the divide the particle's location, which is in pixels, by 20, you'll get its location on the tile system scale. So if you look at this 15 right here for the location of this tile, that's 15 times 20 actually for its position. So what I'm doing here is I'm just reversing that math to get this value so that if I'm inside this tile, I end up with this value. The only issue is that if you divide by 20, you get a decimal. So you want to chop off that remaining decimal. And you don't want to round it either. These tiles are defined by their top left corner. So everything that's on this tile system that's say 15 to 15.9 and 10 to 10.9 will fall under this tile, or 0.999 or whatever. The Python int function automatically truncates the float so that you get just the numbers before the decimal, which is exactly what we need. So I'm going to generate the location string so I can put it into this tile map and see if there's a tile there. This concept is called spatial hashing. It's a kind of weird implementation of it. It's not how it's normally used, but it's very good for particle physics. So I'm going to write this location string. So now that I have this location string, I can check if that location string exists in the tile map. And if it does exist in the tile map, then I know that this particle is inside a tile. And since we assume that the particle is just one point, we know that it can only be inside one tile at once. And if it's in a tile, you just kind of make it bounce sort of back to wherever it came from. I'll show you how you do that in a moment. So if you've seen my physics video, I went over the concept of only handling one axis at a time for collision. So you move on the x-axis, handle collisions, and then move on the y-axis and handle collisions. That way you know which direction the collision came from and you can adjust appropriately. So I'm going to have to generate this location string twice here. This first one's after the x movement, and I can do if loc_stir in tile map. That means there's a collision. Then I can make it bounce. So the bouncing is pretty simple. You just flip over that axis, so the velocity for that axis. So particle 1, which is the velocity, and then particle 1, 0, which is the velocity on the x-axis, equals -1 by particle 1, 0. And then I could just put whatever number I want in here to make the bounce not retain all of the velocity. So I'm going to do 0.85, I think. And the issue here is that this particle is still technically in the tile. So I've checked it's in the tile and I've reversed its velocity, but it's already moved on the x-axis for this frame. So by the time it gets to where my cursor is here, the particle is still inside the tile. So if it gets to the next frame, it'll just try and flip the direction, and it might still be inside the tile. So you kind of boost it out a bit. You apply another movement here. So I'll just do this, and then I'm going to multiply that by 2. So I'm just applying the movement on the x-axis at an extra time. So I'm going to take this and then do it again for the y-axis. So that's the y-axis is velocity, y-axis is velocity, y-axis position, and we should be good to go. Yeah, this is already working. You see these particles are bouncing around in there. They bounce kind of high when they fall down. I'm going to nullify the bounce a little bit more. I'm going to do 0.7. And then I'm going to strengthen the gravity a bit to make it less floaty. And I'm going to make them last a bit longer. So let's do 3.5. I'm also going to dampen the movement on the other axis a little bit after the collision. So particle 1, 0 times equals 0.95. Do it for the y-axis up here. So I'm modifying both of the velocity values upon collision. And here's what that gives us. These particles bounce around very nicely now, and I can do some fun stuff with them. Yeah, that's pretty much it for this video. As you can see, I've got like 1,000 particles or more, quite a bit more actually, I think, just bouncing around. Handling physics fine. I can add a ton of tiles here and it won't really lag. This is the type of thing you have to keep in mind when you're designing your tile system. A lot of my games actually use slightly different tile systems, like the data for it is structured differently depending on what I need for that game. You have to consider things like, do you want particle physics? Do you have layering? How big are your worlds? Do you need chunks to split things up, like I covered in the video on optimization I did a while ago? Yeah, there's a lot of things you need to consider. This is a very simple tile system, and it's not the best. If you want something advanced, you would probably cross this with a chunk system, so you've got multiple dictionaries. But yeah, if you have any questions, you can head over to my Discord server. I've got a channel dedicated to questions there, and I'll be able to answer them pretty quickly if you ask them in there. If you're having any issues with getting this base script to work, I'd recommend downloading this script from the video description, so that you know for sure you've got the right thing. That fixes about half of the issues or more that I see in the comments section. If you're interested in my other projects, you can check out my Twitter. I post a lot of the other stuff I'm working on there, although I haven't been posting too much lately. Hopefully I'll see you guys in the next video.